Okay, so welcome to this little video which will take you through the calculations on the resistivity calculation support sheet. So if you're having difficulty with those calculations, try the sheet first, then watch this video and make sure that you can do them, and obviously ask any questions if you need to. Okay, so question 1 says calculate the length of a copper wire of cross-sectional area 0.65 times 10 to the minus 7 square meters that has a resistance of 2 ohms. First thing we need to do is write down our formula. Resistivity equals RA over L is how it appears on your formula sheet. We want to find L, so we rearrange that, multiply both sides by L and divide both sides by rho, the resistivity, to get L equals RA over rho. Okay? Now that we've got that, we can start putting some numbers in. So the length equals, well, the resistance is 2 ohms. The area, now in this question we're told the area directly, that's very unusual. Chances are in your exam you won't be told it directly. But that's 0.65 times 10 to the minus 7. That's already in our square meters. And the resistivity, well, this is the length of copper. It tells at the top of the sheet that the resistivity of copper is 1.7 times 10 to the minus 8. Okay? Now, what you could do is you could simply plug that now into your calculator. But let's have a look at it. Let's see if we can do something that helps us with that. 10 to the minus 7 divided by 10 to the minus 8 is 10. 2 times 0.65 is 1.3. 1.3 times 10 is 13. So what we've got on the top line is we've got 13. Divide that by 1.7, which is still on the bottom line, and that works out to be 7.6 meters. Given my answers to two significant figures because that's what most of the information in the question is given to. Okay, question 2. Calculate the resistivity of a material if a 2.6 meter length of wire of that material with a diameter of 0.56 millimeters has a resistance of 3 ohms. So here, if we write down our formula, resistivity equals resistance times area divided by length, that's the formula we're going to use. Okay, so I can put some numbers in. So we know from the question the resistance is 3. We don't know the area, but we're told it's got a diameter of 0.56 millimeters. Now this is classic. The area of this wire is going to be given by pi r squared. So let's write our pi in. Now we've been given the diameter, not the radius, so we have to half that. So 0.56 over 2 is 0.28. We need to convert that into meters, so 0.28 millimeters is 0.28 times 10 to the minus 3 meters. And don't forget we have to square that radius. Okay? The length is 2.6 meters, and so that is the sum that we have to work out. So not as nice as the previous question, there's not too much we can do here, but what I would do before typing anything into my calculator, I would rewrite that as 3 pi times, well, 0.28 squared is 0.0784, and 10 to the minus 3 squared is 10 to the minus 6. And don't forget, we then need to divide by 2.6. Now, classic errors people make all the time on these questions are not halving the diameter. So remember, we must halve the diameter to get the radius. Then what they'll do is they will then not square the 10 to the minus 3. You must square 10 to the minus 3 to come up with 10 to the minus 6. Sometimes people will then forget as well to include the pi. So 3 classic errors that people always make. Well, not always, but quite a lot of the time. And then what we can do is we can finish that off. There's not a lot of way we can simplify that, so perhaps typing that into your calculator might be a good idea. Okay, and that works out to be 0.28. I've just typed in the bits in blue into my calculator. I've not faffed about typing in the times 10 to the minus 6 into my calculator, because I know that that will then work out to be that times 10 to the minus 6, and then just rewriting that in standard form will give us 2.8 times 10 to the minus 7. And don't forget the units of resistivity are ohm meters. Not ohms per meter, ohm meters. Right, question 3 then, unusual question this. Calculate the resistance between the large faces of a slab of germanium of thickness 1 mm and area 1.5 mm squared. So what we've got here is we've essentially got a sort of thin rectangular cuboid here made of germanium, and the thickness is 1 mm. And the cross-sectional area is 1.5 square millimeters. Okay, so it's kind of like a very small wire with a rectangular cross-section, often used in circuit boards, something like that. So we've got to be a bit careful here. So again, we're writing down our formula. Resistivity equals RA over L, but this time we're trying to calculate the resistance. So rearranging that equation, we'll multiply both sides by L, and divide both sides by area to get R equals rho L over A. Now we can start putting some numbers in. So the resistivity of germanium, it tells at the top of the sheet, is 0.65 ohm meters. Now the length, well the length now, we've got to imagine we're talking about the current between the large faces, so it's going to go sort of in the direction of the arrow there. So the actual length we're talking about is 1 millimeter, in other words the thickness of that block, if you like, of germanium. So the length is 1 times 10 to the minus 3, because remember this has to be in meters, because our resistivity was in ohm meters. The area is 1.5, but that's square millimeters. Now do not say that, oh, there's 1,000 square millimeters in a square meter, because there isn't. There are 1,000,000 square millimeters in a square meter. So the area is 1.5 times 10 to the minus 6. Okay? Think about that. If you've got a square meter, imagine that's a square meter. It will be 1,000 millimeters across. It will be 1,000 millimeters up. 1,000 times 1,000 is 1,000,000, not 1,000. Okay? So now that we've got that, is there anything we can do to make this easier? Well, yes, there is. We can say that resistance equals, well, 1 times 10 to the minus 3 divided by 10 to the minus 6 is 10 to the 3. So it's going to be 0.65 divided by 1.5 times 10 to the 3. 0.65 over 1.5 to two significant figures is 0.43. So it's 0.43 times 10 to the 3, which is 430 ohms. Right, last question then, number 4. Calculate the length of a section of Constantan wire of diameter 0.32 millimeters that has a resistance of 10 ohms. So, once again, we write our formula down. Rho equals RA over L. We rearrange it by timesing both sides by L and dividing both sides by resistivity to get L equals RA over rho. Now that we've got that, we can start putting some numbers in. So length equals, it tells in the question the resistance is 10, but once again we've got a diameter in millimeters which we're going to use to work out the area of this wire. So it's pi r squared, so it's pi times. Don't forget to half the diameter, so it's 0.16. That's in millimeters, so times it by 10 to the minus 3 to get it into meters. Don't forget to square it. Divide by the resistivity of Constantan, which tells us at the top it's 47 times 10 to the minus 8. Lots we can do here to simplify this. That's going to be 10 pi times, well, 0.16 squared is 0.0256. 10 to the minus 3 squared is 10 to the minus 6. And divide all that by 47 times 10 to the minus 8. Well, we can cancel that 10 there with that minus 6 there to create that as minus 5. We can then cross off the minus 5 and divide that by 10 to the minus 8 to get on the top line 10 to the 3. Running out of space here. So it'll be 0.0256 pi divided by 47. Okay, so 0.0256 pi divided by 47, that equals 0.0017 times 10 to the 3, which equals 1.7 meters. Okay, so hopefully by going through that sheet yourself and by seeing me go through it on this video, you followed those questions, you understood the basic errors that people make loads and loads of times. As I say, not halving diameters, forgetting to square things, sometimes missing out pi, and hopefully you're now aware of how to do resistivity calculations to the standard you need to do for AS physics.